Hai, Assalamualaikum warahmatullahi wabarakatuh. Okay, yeah, welcome back, and we will continue on normalization 2, still learning by example, right? And we will use the same example, previous example is on students' grade report, okay? And okay, previously we learned how to identify FDs. Now we learn how to identify 1NF, 2NF, and 3NF. Okay, this is we call normalization process. Okay, first of all, once you look at the table, this table given to you, right? You have to identify first. You see this table is 1NF, right? If you look the first table here that given to you, you can see that there's empty cell here, empty cell here, all right, and you can see that it exists repeating groups, especially in subject, credit hour, and grade. All right, repeating groups. Okay, for the metric student P1234, repeating groups for metric students P1356. So we can see that. Okay, this is not 1NF table. Alright, this is UNF table. In other words, is once you look, this table is incomplete. Okay, have this empty cell, automatically we can see that this is UNF table. Right. We have also steps on identify this 1, 2, 3, and F. So the first step for 1 and F, okay, you have to fix the 1 and F by entering data. Okay, previously the red one is empty cell. The red one is empty cell. So you have to enter the data in this empty cell, right? Okay. And the next step, you have to identify PK. Previously, okay, remember we already identified the PK, okay, to determine the FDs, okay, the PKs that are relevant is metric and subject, right? And, if you look at here, once you identify the PK primary key, okay, the difference compared to previous table, okay, the attribute is not underlined yet. Okay, if we identify the PK, so you have to make sure that the attribute should be underlined. Means that this is the sign that this is a PK, right? We have two PKs, metric and subject. So now, is it complete? Yes. Okay, this is complete table of 1 and F. We have tips actually. Okay, the 1 and F table, there are no repeating groups, means that there are no empty cell here. Okay, all the key attributes are defined. We have metric and subject. And then make sure that all attributes, non-key attributes, should be dependent on the primary key, subject and metric. Yeah, this is tips for 1 and F table. Alright, step the next step for 2 and F. Okay, 1 and F is completed. So we go to next 2 and F. We have steps for identify 2 and F. First, okay, determine FDs. Actually, we already discussed on the previous explanation, okay, on normalization 1. Okay, how to fix 2 and F. Okay, you have to list first, okay, the FDs. Okay, we have techniques. I want to share the techniques, okay, by illustration on dependency diagram. Okay, you take all the attributes here and you illustrate the 1 and F diagram, right? 1 and F, key, metric, and subject, okay, should have no arrow. Determine another's attribute, means that non-key attribute. Okay, non-key attribute should have arrow, right? So metric and subject determine non-key attribute. Okay, this is 1 and F. Okay, so we know that previously we already determined all these FDs. Okay, we know that the first FD is metric determine student's name, address, proc codes, proc name. Okay, subject, determine credit hour, metric, and subject. Okay, determine grade. Okay, actually, if you don't know what determine grade, okay, you can see that from 1NF illustration, you can remove the non-key attribute like this. Okay, which it is a repeating group, right? Okay, student name. Okay, non-key attribute from FD1 and FD2. Okay, you slash it here. Okay, address, slash it here. Proc codes, slash it here. Proc name, slash it here. This is FD1. Okay, FD2, you know that the non-key attribute is credit hour. So, you can remove the non-key attribute here. Okay, in 1NF. And then, uh, uh, it comes out to another FD, means that metric and subject determine grade. Okay, FD3, metric and subject determine grade. Right, and we have also another FDs, okay, which non-key attribute determine another non-key attribute. Prop code it is not a key attribute, right? This is not primary key. Okay, this is non-key attribute. So prop code determine prop name. So we can say that this is transitive dependency. Okay, this is primary key. This is partial. Okay, this is partial. Anything that dependent on a part of primary key, we call as a partial. If the entire primary key, we call as a fully functional dependency or primary key. If non-key is dependent of non-key attribute, we call as a transitive. Okay, this is a very important part because it can make you more easier to identify uh, uh, 2NF and 3NF, right? Okay, this is the technique for normalization process. Okay, right. Then what to do? So you had to identify partial. We have partial or PK. So partial, we have FD1, FD2, and the primary key is FD3. So you remove. Okay, you have to remove all these three FDs. It comes with table, right? So we can produce, remove FD1, remove FD2, remove FD3, and you can produce three different tables. Okay, you have to put your own table name for each FDs. Okay, for the FD1, from the FD1, you can say that this is the info of student, so you can put the name, table name is student in the bracket. Okay, this is the format, standard format, okay, to create a statement for table. Okay, table name, you set as a student. Table name should be related with the attribute here. Okay, this is about student, so you put the table name student, which this is the primary key and this is non-key attribute. Right, from FD2, okay, this is related of subject, put the table name subject. This is a key attribute, this is non-key. Okay, this is about grades. Okay, the info of grade, so put the table name grades. This is a key attribute, this is non-key attribute. This is from FD3. Just remove all the dependency except transitive, right? Okay. Okay, complete the table. Okay, you have to complete the table student, grade, and subject. Okay, you can see that, okay, you don't have any redundancy, okay, in each table. For subject, okay, metric, and combination metric and subject. This is a unique key. Okay, you can produce that the table for 2 and F don't have any redundancy. Right. Okay, and make sure that 2 and F consist transitive dependency. Where it is inside the student table. Prop code and prop name. Okay. Okay. Next is 3 and F. you have to identify first transitive. We have one transitive here. Prop code, determine, prop name. Okay, what to do? How to fix it? Okay, so you have to split actually. Yeah. Split from the table student, prop code and prop name. You split uh, another two tables, student metric, student name, address, and you have to leave the foreign key for prop code. Okay, and another table is about, because prop code and prop name is about program, so you put the name, the table name is program. So the related attributes prop code and prop name, and you can put the prop code as the new key or primary key here. All right. So this is how to split from a transitive from the table student. Okay. And then, as usual, you have to complete the table for student, grade, subject, and program. Okay, altogether we have four different tables for student. Okay, we have matrix, which is a primary key. We don't have any redundancy here. Subject is a primary key. We don't have any redundancy here. Prop code is also same. We have no redundancy here. And combination, metric, and subject also, we don't have any redundancy here. Yes, it's already 3NF. Conclusion, 3NF and ER actually, okay, how it relates together. Okay, let's say you look at us table students, it relates with program based on the foreign key prop code. Okay, grade table, it relates with students table because of the primary key metric here. Okay, grade table to subject table, it relates because of the subject key here, and also the subject here on subject table and also grade table. Right, and actually we can transform to ER. So it's relate to, okay, it's relate to NF and ER, and actually this is a bottom up approach on database design. Okay, right. Okay, I think that's all for today. So we will continue on Q&A, question and answer, normalization. So I think that's all for today. Good luck and see you then. Bye bye.